All right, I'm going to try a new format here. This way I can handwrite things and I don't have to be stuck loading things like this into PowerPoint or anything else. So what I've done is I've decided to find a new magic number. If you'll notice in the upper part of that triangle tau with the inches sign, okay? And then I don't need to worry about the squared number of beats per minute, and we wind up getting the radical of the inches. That I represents inches. So I got rid of meters because in Crotch's day he used imperial inches. And there was a discussion here about imperial inches and Rhenish inches that I saw on Facebook, or the several different types of inches. They didn't vary much, okay? Let's compare it to the metric system, which was pretty much constant. The imperial inch was 2.54. The Rhenish inch was 2.61. And if there were other inches, it doesn't really matter. They wouldn't vary that far out. As a matter of fact, Weber's treatise, I think it was 1840 or in the 1840s, he describes how to make a pendulum and how to use it. And to do that, he says, the wideness of the string or even a ½ inch to an inch off is not a deal breaker. It'll get you close. It certainly won't give us the solution to our whole beat metronome practice versus our single beat theory. So what I've done is I've revised the triangle where tau is going to become a new constant. Okay, so I'm taking that old triangle paradigm, and I'm now going to make the number, that n, beats per minute, equal 375 over the square root of I, which is for inches. So how do we do that? How do we get there? Okay, so we do have meters. So if you remember from the triangle, to get the meters of the pendulum, you take tau, the constant, 3577, and you divide it by the beat rate squared. Okay, so that's equal to m. So what we do a lot in math is we just replace that into our inches formula. Now, how do we get from meters to inches? Well, you multiply the meters by 100 and divide by 2.54. Okay, multiplying by 100 gives you centimeters, and we know that there's 2.54 centimeters in an imperial inch, or as we call it today, even because Britain gave up on it, we now call it the United States customary system, and we still use that in physics, sadly. Anyway, there is a place for it. I really do find this new formula in inches a lot easier to use if I don't have a calculator. And an inch is about the distance from your thumbnail to your first knuckle on your thumb. That's about an inch. If you just actually measured that out, your standard piano keyboard, I believe that's about 8 to 9 inches to an octave. So if you just measure it along your piano, figure it out, and you can get inches real quick. So first thing we did was replace m with what it equals, 3577 over beat rate squared. All right. Now we're going to start doing some multiplication. I multiplied by 100, and that gives us 357 700 over n squared over 254. Now to divide a fraction by another fraction, you have to multiply by the reciprocal. So I'm essentially going to take the top fraction, 700 over n squared, and multiply it by 1 over 2.54. In essence, I'm dividing 357,700 by 254. That gives me 140,826.77 over n squared. And we have to square root both sides because, again, I wanted to get rid of the n squared term. So we square root the right side, we square root the left side. We now have the square root of inches equals the square root of 140,826 over n squared. I truncated the value of 77, that 0.77 from the previous slide. There it is. I got rid of it. It's not going to matter. Trust me, it's not going to matter. This number is huge, 140,826, and we're going to worry about 77% of 1 unit. It's 0, okay? And when I get the square root of that number, I'm going to have now the square root of I equals 375.27. Now I have another decimal to deal with. But look, our beat rate in the denominator is now a whole number, or a regular number, whatever number you want to use there, in fact. So I kind of highlighted 27 because I'm also going to just truncate it. Truncate means to literally put a line through the decimal point and just throw it away. Why? Well, at 40 beats per minute, which is the minimum of the modern metronome scale, you will have 0.02 as a decimal. And if you're beating 40 per minute and you're worried about 0.02, you have bigger problems than just worrying about your tempo, friend. Even all the way up to the modern 208, we're dealing with 0.15 of a beat per minute. So you would need 10 minutes just to gain one beat on that 208. Again, I don't remember a piece of music even having a 208 on it, but you know, whatever floats your boat, man. So I'm going to cut that off, and we're going to go ahead, and now we have a pretty decent formula here. Square root of I equals 375 over the beat rate. But what if we are given inches? Well, what we're going to do is multiply both sides by n and then divide both sides by radical I. Essentially what you're going to do is you're going to take the radical I, throw it in the denominator, and take the n and put it where the radical I was. Boom, we do a switcho, presto, changeo. And we have now the beat rate equals 375 over the square root of the inches of the pendulum. So that is our new constant, 375. It looks like the other one a little bit. I mean, the other one for meters is 3577, and this one's 375. So here we go. We have now t in inches. Our tau, I just put inches there kind of to separate it from our tau, the original magic pendulum number that I used, okay? And then we have beat rate, and now we have the square root of inches. So essentially, if you're given n, then you divide the square root of the inches into t, which is 375. If you're given 375, multiply your beat rate times your square root of inches, and you will always wind up with 375. And if you're given the inches, take the square root of those inches, okay, and divide it into 375, and you'll automatically get your beat rate. Super easy formula to use. Again, that t is always in the numerator, and you can think of it as being divided by either part of that triangle, or if you multiply straight across your n beat rate times your square root of your inches, you will always come up with the 375. Quod erat demonstrandum. All right? And that'll do it for my presentation. So go ahead, like, subscribe, share this video. If it comes up again on Facebook, somebody's asking, Crotch put 14 inches. What the heck what is that in our beat rates of our modern metronome? Of course, in the whole beat metronome practice, you're going to divide that by 2 to get revolutions per minute. That's really how everything on the planet functions. Everything has a complete circle, not just half a circle. Maybe I'll do a video on that someday. All right, you guys, enjoy. Bye.